All right, we are starting chapter 5. So 5.1 is kind of an introduction to the types of problems we're going to see in chapter 5. So we're going to look at what are called street routing problems. And these are problems that make a lot of sense when you think about it. These are things you would definitely want to find solutions to. So things like, how does the UPS manage to deliver 120 million packages in a single day? Or how do garbage trucks have time to collect all the trash for millions of people? So this all deals with a section of mathematics that most people have never worked with before, and this is called graph theory. Now, graph theory doesn't have anything to do with like graphing lines on an XY coordinate. This is a completely different type of mathematics. So we're going to be looking at figuring out solutions to street routing problems. So street routing problems try to find ways to deliver goods or services to an assortment of destinations. Okay, so when we're looking at a street routing problem, we're really interested in two questions. The first question is, does a route exist? Okay, so does a route even exist that will do what I want it to? And second, what is the optimal route? Now the word optimal doesn't necessarily mean cost. It could be the least cost, right? So we always want to save money. Now, when I try to run all my errands around town, I am interested in the least time. I don't care if I drive a couple of extra miles. I want to get my errands run as quickly as possible. So for me, the optimal route would be the least time. And you might also be interested in the least distance. So some examples of street routing problems. Number one, a security guard is hired to patrol every street in the neighborhood. He's required to make an exhaustive patrol on foot through the entire neighborhood. He's interested in finding the optimal route which starts and ends at the same place, which is going to be where he wants to park his car. Is it possible to cover every block and pass each block only once? Is there a better route if he chooses a different starting and ending point? Okay, so that's an example of a street routing problem. Number two, a mail carrier must deliver mail to the same neighborhood. However, he must make two passes down each street to deliver mail to both sides of the street if houses are present on both sides. Only once if there are only houses on one side. He will not have to travel down a street if there's no houses on that street. He is also looking for the optimal route. Number three, a UPS driver in the same neighborhood only has to travel down streets that have a delivery. He is also looking for the optimal route. So this gives us some ideas of the types of questions we like to try to solve with graph theory. So these are very kind of practical, real-world questions. Now, graph theory came about from kind of a famous street routing problem, and this one's called the Königsberg Bridge problem. So Königsberg was a city with a river running through it, and it had two islands in the river. So there were 7 bridges connecting all the land masses. So a game was played by the locals. They would try to take a walk around town, fully crossing every bridge once and only once. Okay, so the idea is you start and then you go back home. Okay, so they could never complete the game successfully. However, they weren't convinced that it couldn't be done, just that they hadn't been able to achieve it yet. So just to kind of give you an idea how this problem is set up. So this is supposed to be the river running through the town. So if we think of pink as being land masses, sorry, I don't have a green highlighter with me. Okay, so here's one bank of the river, so all of this is land. Here's the south bank, so all of this is land. And then the islands in the middle are land. And then each of these marks are going to be bridges. So I'm going to use blue for the bridges. So there's 2 bridges going from the north bank to the first island, and then 2 bridges going to the south bank. On the smaller island, there's a bridge going north, a bridge going south, and then the very last bridge connects the 2 islands. So the idea is to start in one place, maybe the north bank, cross every bridge one time and go back to where you're going to start. So later on, when we start learning how to solve street routing problems, we'll come back and we'll look at this one and we'll see if it is possible for them to cover each bridge once and only once.